A valve body can be cast accurately, machined cleanly, and still be wrong for the final assembly. The risk begins when the customer drawing, material requirements, inspection plan, and approved manufacturing changes no longer point to the same production definition. Preventing that failure requires one controlled baseline. Four records must remain aligned: the customer-controlled drawing or approved model, the material and specification list, the shared DFM review and response log, and the inspection and release plan. Every record should carry consistent part numbers and revision identifiers, so geometry, materials, manufacturing decisions, and acceptance evidence remain traceable. The customer retains authority over intended function, valve architecture, material specification, pressure and service requirements, interfaces, acceptance criteria, and final assembly validation. The manufacturing partner controls process planning, tooling, casting, machining, in-process verification, and documentation against the release package. This division allows the supplier to contribute practical manufacturing expertise without taking ownership of the product definition. That distinction is critical during design-for-manufacturability discussions. A supplier may identify a feature that is difficult to fill, fixture, machine, measure, or inspect. Concerns may involve section transitions, core support, feeding paths, shrinkage risk, machining allowance, datum strategy, tool clearance, or wall stability. But the proper output is a documented observation, not a silent design alteration. The first verification gate is manufacturability review. Each issue should identify the relevant evidence, likely manufacturing consequence, and available options. The customer can retain the original requirement, issue a revised drawing, or approve a documented deviation. The second gate is customer-approved change control. A clarification that does not alter a requirement may be closed through a controlled interpretation. Any proposal affecting geometry, material, inspection extent, acceptance requirements, or interfaces requires customer authorization and an updated record. The release package must show what changed, why it changed, which requirement is affected, and which revision governs production. File precedence must also be explicit. A physical sample can provide valuable assembly context, but it may include wear or undocumented legacy modifications. A 3D model may support pattern development or machining, yet it should not override the controlling drawing without direct customer instruction. Emails, spreadsheets, bubble drawings, and marked files can support the process, but they must be incorporated into the controlled package. Access discipline then prevents an obsolete model or drawing from reaching the shop floor. The third gate is first article verification and release. Here, the actual component is assessed against the approved baseline before repeat production magnifies an error. Evidence may include material identity, chemical analysis, mechanical property records, dimensional results, pressure testing, and non-destructive examination such as MT, PT, UT, or RT when required. The precise method, coverage, acceptance criteria, and reporting expectations must come from the project requirements. Inspection planning should begin before manufacturing, not after the part is complete. It must define what will be checked, when verification will occur, which record will be produced, and how exceptions will be handled. In-process checks are especially important where later machining could remove the opportunity to verify a cast feature. Each report should identify the part number, revision, applicable acceptance criterion, and traceable lot. If a first article deviation is accepted, its scope must be recorded. Approval may apply only to one sample, a stated quantity, or a new controlled revision. Without that distinction, a temporary concession can become an undocumented permanent change. After release, tooling, casting, machining, inspection, packaging, and document control must all receive one unambiguous baseline. Repeat orders should be checked against the latest revision, authorized deviations, material requirements, and reporting package rather than relying on a familiar part number or historic route. A disciplined release process does more than preserve paperwork. It keeps customer design authority intact, converts manufacturing feedback into controlled decisions, and ensures that every production record supports the same approved valve body.